So in the last couple of videos, I have given you a description of most of the particles in the standard model of particle physics. We started with the gauge bosons. These are particles that mediate forces. We then went over to the leptons, which are particles which do not interact by the strong force. And then the quarks, which are particles that do interact by the strong force. There is one particle we're missing from this description of the standard model of particle physics, and that is the Higgs boson. We only observed the Higgs boson in 2012, costing us £13.2 billion. The reason it was such big news is because it was the last piece of the standard model we have found. The reason it's so important in the standard model is because it gives you a mechanism by which other particles gain a mass. Particles are associated with fields, and the Higgs boson is slightly unusual in that in the vacuum state, or the lowest energy state, that field has a non-zero value. This is called a vacuum expectation value, or VEV for short. And it's this vacuum expectation value, this non-zero field in the lowest energy state, which is responsible for giving other particles mass. You can roughly think about it as those particles having to move through that field, and that field causing some resistance to the particles. So that is the Higgs boson.